Okay, let's jump straight into it. Chapter 11 study guide. This is the unit basically focused on circumference, area, and volume. As long as you can identify the shapes that are given in this unit, you should be able to apply the formula for whatever it is that they're asking you to find. Take circumference of a circle. Circumference, oh, that's terrible. Circumference is given by the formula C is equal to 2 pi r. That's basically the length around the entire circle. And so as long as you can identify what is what, in this case r is 6, well, you know that's going to just go straight into here. So that's just going to give us 2 pi times r. In this case r is 6. If you multiply these two together, that should give you 12 and 12 pi, because pi drops down. So let's write that in. That's 12 pi. That answer, if you punch into a calculator, 12 times 3.14 approximately is about 37.7. If we were to write the units, think about it. We just found the circumference. This that we found is just a circumference around a circle. That is a length. Length is one-dimensional, and so this is just to the 1 power. But we don't need to write the 1 power. Let's do number 12, find the area of the circle. Again, in this case, area, really simple. Area is just pi r squared, different formula. Well, r in this case is 11.7, right? And so that is going to be pi times 11.7. Well, 11.7 on your calculator, you can calculate that. And whatever number you end up getting, you can just write it here, times pi. But I'm just going to go skip the step. In fact, I'm just going to write the approximately simple, go straight to decimal. If you plug that whole thing into a calculator, you should end up getting 430.1 kilometers squared. Why is it squared? Well, this is a two-dimensional area. It's no longer just a one-dimensional line. It is two-dimensional. It's just a flat surface. Well, that region is basically 430.1 kilometers squared. Find the area of each of these figures. Okay, well, what kind of figure is it? Well, this one is what you call a trapezoid, right? And if you just peer down at these list of formulas, a trapezoid basically has that formula right there. In other words, it's just a plus b divided by 2 multiplied by h on the outside. That gives you the area of this figure. Well, let's label everything. Oh, geez. A is going to be 6, B is going to be 2.8, H stands for height, and so these are the three values that we're using, right? So as long as we plug them into the proper position, right, we should have no problem. And so that's going to be equal to, what is that, 6 plus 2.8. Ooh, that's kind of ugly. Oh well. And then if we simplify from here, 6 plus 2.8, right? If you simplify those, that's going to give you 6 plus 2.8 is going to be 8.8. And if you simplify 8.8, well, that is going to give you 4.4 multiplied by the 4 on the outside. Well, that should give you, again, 17.6 inches squared. Again, we're finding the area. Area is two-dimensional. And so this is going to be your answer in units. Take this example. This is a kite. I'm not going to scroll back down, but the formula for a kite and the area of it is basically half of the two diagonals multiplied with one another. And so it doesn't matter which one you call diagonal 1, diagonal 2, but these two are the values. Well, that's just 1/2 times 9.8 and 11. Now, you could just multiply these up, and then you could just say divide by 2, means the same thing. For the sake of time, I do want this video to be pretty quick. All three of these numbers, right? If you multiply 1/2 times 9.8 times 11, you should end up with 53.9 miles. And it's squared once again because we're dealing with area. We're finding the area of this kite right here, right? This shaded region, two-dimensional. Okay, making good time. Let's find the volume of each figure. So volume of each figure. So round your answers to the nearest hundredth if necessary. Well, the volume is going to be given by 4 pi r cubed over 3. Well, long as you can identify the radius, again, radius is 10. That's going to be just 4 pi, plug in the 3, plug in the 10, I mean. I guess I switched up the colors. And then if you wanted to really simplify, well, this is going to be 4 pi 10 to the third power. That's really, it just simplifies to 1,000, right? We're not going to simplify for all of them, but now these two, if you multiply 4 and 1,000, that gives you just 4,000 pi divided by 3. At this point, just plug that into a calculator. I mean, you could have just went straight from here to this answer on a calculator, but it's good to know how to show the work for this. If you punch this into a calculator, you should get this value, but it's going to be in kilometers cubed because we're dealing with volume, and volume is three-dimensional, right? You look at the sphere. It is no longer just a flat surface. We look at number 6. Let's identify the height and then the radius. Okay, good. Let's do volume is equal to pi r squared h is equal to pi whatever squared. Well, if we plug these in, be very careful. I got these colors wrong again, but this one should go here. That's height. This one should go in here. That's radius. And so 7, 4, well, that's going to give us pi times 16 times 7. And if you wanted to simplify it, totally forget what that is. 16 times 7, that's 112 pi, right? If you wanted to multiply it out. And then that is approximately going to be 351.86 centimeters cubed volume. So it's cubed. Okay, this is a cone. Remember, cone is the same formula, right? Pi r squared h, except it's a third of the size, so we're going to divide it by 3, whatever answer we get at the end. And so identify your height. The height is going to be 9. The radius of this circle on the bottom is going to be 4. And so if we were to plug it in, well, this would give you 9. This would give you 4. That's going to give you pi times 16 times 9 divided by 3. If you wanted to plug it into a calculator, you totally could. Well, I'm going to do a pro move here. Actually, no, I'm not. Who am I kidding? I am no pro. And I'm at school. I have to go home. I'm just going to speed run this. This is going to give you pi times, if you multiply these two out, that's going to give you 144 divided by 3. Well, 144 divided by 3, that's going to be equal to 48. So 48 pi And it turns out if you simplify that on a calculator, you should get 150.8, not centimeters. The problem says meters, so this is going to be meters cubed. Number 8, I love these because at least for volume, it's really simple. Remember, it's just like a square, length times width, but it has a third dimension, so it has to be multiplied by height. Well, what is length? What is width? What is height? Look, guys, it doesn't really matter. I mean, it doesn't matter because it depends how you look at the box. But in this case, I'm looking at it kind of as if this is the side that's standing. Honestly, it doesn't matter. It doesn't matter how you look at it. Like, I'm looking at it as if it casts a shadow kind of like this, you know? So I'm just going to treat this as height. I'm going to just treat this as length. I'm going to just treat this as width. As long as you pick 3 different sides, you're good. I mean, you're going to be plugging in these numbers anyways, as long as you differentiate them. So that's going to give you 9 times 7 times 12. Well, 9 times 7 times 12, that's going to give you 756 centimeters cubed. You could have multiplied that in any order, and you would have gotten the same answer, the volume of the inside here. That is terrifyingly ugly. Oh, it's bothering me so much that I'm going to... There you go. Okay. Oh, terrible. Let's move on. Number 9. We have given the height of this pyramid, and we have our width, and we have our width. Oh, actually, what am I saying? Backtrack. This is, again, length, and then our width, right? This is our height. Sorry, I don't even know why I had to erase it. So we have 3 different details here. Well, the volume of a pyramid is the same thing. It's length times width times height, but remember, it's a third of the size. It's a lot smaller. It's a third of the size of a rectangular prism. So whatever 3 numbers you get, you have to divide by 3. And so in this case, length, width, height, what is that going to become? 2 times 2 is 4. 4 times 4 is 16. So this is going to give you 16 over 3. Ooh, that's ugly. Well, 16 over 3 is just going to be equal to approximately 5.3. If you end up getting 5.3 with that line on top on your calculator, well, that's just another way to say it goes on forever, right? So we're just going to round it 5.33. This is volume, so it's 5.33 kilometers cubed. That's the volume. Summary of the formulas here. And again, try to think about it in a logical sense, right? Each of these can be very easily done logically. I think if you memorize the formula, you're more likely to forget it. But if you understand where it comes from, like I talked about in class, you should be good. Okay, last section. This is the section on surface area. Surface area is going to be a little bit more challenging for our little people. Little people. I don't mean small people like me, but it's not a good hour. I gotta finish this. This is 4 pi r squared. This is gonna be the surface area of a sphere. Okay, refer back to 11.4. Okay, well, you have your radius. Your radius in this case is 10. Fantastic, right? This is your radius. And so this is going to be 10 squared. Well, 10 squared is just 100. And then if you multiply 4 times 100, that should give you 400. And then this pi would just drop down. So 400 pi. Well, 400 pi is going to be approximately 1256.64 kilometers squared. And think about it, it's squared because you're kind of flattening this out. You're flattening it out into just a 2-dimensional shape, right? And so this is really just the surface area, which is 2-dimensional. Here's a sideways cone, right? Think about it, like just read it like this, right? if you read it like this, the slant height is 13.4, and then the radius is 6, right? Radius is 6, slant height is 13.4. So the slant height, or sorry, the SA, which is the surface area, is just pi r squared plus pi rs, the slant height. And for this one, again, we don't really, I mean, it's good to simplify, but these numbers are kind of ugly. Plug in 6, 6, and then, let me zoom in here. I'll just write it a little smaller because I can't fit it, 13.4. And as long as you plug this into a calculator, like all at once, which again, I'll let you do in this case, you should end up getting 365.68 inches squared. And that's your surface area. It is not your volume. Volume is like the total weight. Imagine like liquid content. If you poured liquid into a cone, that would be the volume. This is not volume. This is, if you were to kind of, if you're trying to trim this in half, right? If you cut this in half, well, then you would get some kind of like flat surface, maybe more triangular, maybe something like that. And then your little circle on the bottom, that would be this. And that would be your area. Okay, let's identify a couple things. Just to kind of drive home the point, it doesn't matter. I'm just gonna treat this like the height, right? It doesn't matter how you look at it. If we call that height, look, let's just call this length. Let's just call this width. I mean, it doesn't matter, as long as you just identify 3 different variables. The surface area formula is just adding up all of the areas of each individual face. Like, there's 6 faces to this, right? 2 and 2 and 2. And all we're doing is we're just plugging in the values for each of these. Oops. Actually, interesting thing here. If you're watching this, let me show you a little life hack, just to reward you. You guys can actually factor out this 2, right? Factor it out so that the 2's on the outside. And then the only things remaining are these. And in fact, in my opinion, I prefer that because then I don't have to multiply 2 a bunch of times. This is just algebra 1 simplification. Again, we factored it out, right? It's like anti-distribution. We factored it out so that only 2 is on the outside. And then at this point, let's multiply some of these numbers. We have 12 times 3, length times width, plus, what is that? 12 times height, which is 7, and then 3 times 7. And if you plug that into a calculator, you should end up with 282. And since the box was in meters, it's going to be meters squared because that is going to be the surface area. If this threw you off, again, you can just follow the same formula, the same way that we've been doing. I believe the way I wrote it down on the answer key that I posted online looks the other way. 13. Okay, again, this is the slant height. It's slanted height. Notice how it's not just like straight down the middle into the center. That would be regular height. So S for slant height. Let's call this the width. And width for this kind of square pyramid is going to be the same because if you look at that, it's supposed to be a square base, which has equal sides. So as long as you have that, surface area is going to be 2ws plus w squared. Well, if you plug in your numbers, width goes here, width goes here. Gotta shrink this again. This is 3.6, that's the slant height. You have my word that if you plug this whole thing into a calculator, you should get 44.8 kilometers squared. Fantastic. Now, before I crash out, and I don't know when you're watching this, maybe that's not slang anymore, let's finish this last one. So again, this is kind of a sideways, I mean, if you want to redraw it, you can, but this is sideways. This would be like looking at it like this. This is 11, R is 11, and then height is going to be 9, right? And the surface area formula, right? This formula is going to be the surface area formula for a cylinder. And the way you can think about this one is that you have a top of the circle and you have the bottom of a circle. That's the area of those two, right? And then you have 2 pi r h. Well, that's given by if you were to peel this away and you basically get like a little rectangle. The height is h and 2 pi r is going to be the other length. And you multiply those two to end up getting these. Anyways, if that went over your head, that's okay. My hope is that you will cover its derivation and appreciate it more in its full details as you move on in your math career. Please. But in any case, let's move on. This is going to be, if we plug in radius, again, don't mix up the radius. You have to plug in radius where the radius is. And then the height is going to be 9. Well, my hope is that you know how to simplify these. But this should become, think about it, it's going to be 2 pi times 121 plus 2 pi times 99. And then that's going to give you 240, whoa, what's going on? 242 pi plus, I'm ashamed to admit, I don't know 99 times 2 out of the top of my head. That is 198. 198 pi. And if you add up those two numbers, you should end up with 440 pi. Right? These are like terms. They both have pi. And then finally, if you get the decimal approximation for this, that should give you 1382.3 meters squared. Because technically there's an invisible 0 here. So that's still to the hundredths place. Fantastic. And there you go. Here is the summary of all the surface area formulas. I'm ready for school to end.